Hello and welcome to this continued series on HTML5 game dev. So recently I have played around with one of the HTML5 gaming engines. It's called PixiJS, and I have played with a few others historically, but years back, or looking at how Unity can export to HTML5. So this was really my first foray into doing JavaScript in, I don't know, a long time. Learning the alternatives and improvements of TypeScript. So everything I'm about to show is actually with the TypeScript superset of JavaScript, which I think is much better, and using PixiJS as the engine. My name's Sam. I'm a game dev with over 20 years of experience. I have lots of experience with Unity the last decade or so, using Unity for most everything that I've done, both as a game dev and an educator. Within Unity, I have shipped titles for iOS and Android a lot, as well as some PC and Steam stuff and a bit of console. I haven't done much work in the browser since back in my days doing Flash gaming way back when. So I'm interested to step back into HTML5, back into the world of the browser, and see what's possible. I'm really fascinated to see how HTML5 as a technology stack and a platform on which your users can find your games, how it fills in the niche in the game dev industry. It's certainly awesome for your users not to need to download anything. They can just play your game through the mobile browser or the desktop browser. I'm enjoying learning HTML5. It is totally new to me, but if you are looking forward to learning some more stuff too, check out this link. I've got these videos as well as some articles, some repos like the one I'm going to show today, and some tips and tricks. So let's take a look at this PixiJS project template that I've created. So when you're getting started learning any type of game dev, including HTML5, you first pick what type of engine you want to play around with. In this case, PixiJS. It's a real popular one that's out there, and the newest version, V8, that I'll be showing is really powerful as well. Then pick a code editor to work within, or some of these tools have a dedicated game editor or level editor. PixiJS does not, so you just pick any text editor you want. I'm using VS Code. And then make some sort of a demo. So when I sat down to learn this just recently, it took me a while just to get the very first part of it published, because I needed to figure out, well, like, how do I actually deploy this and how do you run it? You have to do some command line stuff. So after I learned that, I put together a new starting point that I can recommend that everyone check out. So what I'm about to show here, you can feel free to fork and get started if you want to learn some PixiJS too. And it'll be much easier because everything's really laid out for you. So here on GitHub is my Pixi project template. It's a great place to get started. I wasn't able to find anything else like this that is updated, but there may be some other stuff out there. It was a joy for me to learn as I went and to put this together. So I hope you enjoy forking it and checking it out. I'm going to go through the README quite laboriously here because there's some interesting stuff I wanted to talk about. So this game template is specific for the PixiJS game engine. In the getting started area here, I broke it down so that you can just play the end product. I also, when I fork this to make my own games, I'll be able to use the same format. So jumping right to playing the end result, and then if you want to download and build the project yourself, you can do that. So let's just start by browsing to the first link here. Now here is the project template running. So what we're looking at here is an HTML5 page. That page has some CSS applied to make a nice border. Then everything that's blue and inside of that is the PixiJS canvas being rendered. I've got one sprite here that is running code every frame. There isn't any interactivity to it per se, except you can resize the window and the graphics stay centered and scaled properly. So just a simple example and a nice starting point. You could take this and be able to add more sprites to it and be able to add interactivity to it as well. But it's a great place because you've got a nice development workflow that I'll go over here. So if you were going to build the project, which is what I found to be really tricky in my first day of learning doing HTML5 and PixiJS, you'd want to download this repo. Then we'll use some command line tools to run some commands to get this repo set up. Now, if you are experienced in the web dev world, this will not be new to you, but it had been a long time since I'd done anything like this. So just running these type of command line tools to kind of build this first project was a bit weird for me, but I learned it and I ended up quite liking the power and flexibility of it. So going through step 2 here, you run some commands to install the dependencies you need. So my project, when you download it, has the recipe for all the dependencies that are needed. all the dependencies are free, and you run this npm install, and it goes and fetches them for you. That's not something you commit to Git. Every dev on your team would just have their own local copy of those third-party libraries. Then you can run one step to build the project, and then one to start it. And when you start it, it runs in a local server on your computer. So you can get really nice workflows of having your project be automatically rebuilt periodically. And it's really nice to work within. I liked it a lot. Then let's see, you play the game at that local host, and then whenever you're done, you know which subfolder you need to upload online in order to have that playable link like I just showed you a second ago. Then after you get all that stuff going, you would open the PixiJS folder in your Visual Studio, or I'm using VS Code, but you can use any text editor you want. And that's where you do the majority of your game development. Now, what I thought was really cool, and I'll show you a quick demo of it as we download this here and get it started, is that every line of code that I change, it just automatically rebuilds the project. So your development workflow, which we'll see in some screenshots below, is do a little bit of coding, look at the browser. Do a little bit of coding, look at the browser. You don't actually have to rebuild except for certain types of changes. So I included a link here for Webpack Beginner's Guide. There's certain situations where you do need to do a rebuild, and I'm still learning it. But for a lot of little changes, you can just add a little code and see that reflected in the running game. So those commands I have there are the required minimum, but there's lots of other ones. So I made this nice table here. You can see the different commands that you can run. These aren't all necessarily boilerplate available in every repo. Some of these I customized and made myself, but you can see which one builds the project, which one runs it, which one runs unit tests, which I'll talk about in a future video. Unit tests are not part of the original setup, let's say. In some game dev circles, people don't even use them, but I strongly recommend, if you're getting into game dev, that you include CI/CD and unit tests in every project you do, and I'll be talking about those in a future video. And then lastly, which one watches. Now, watches is kind of a new concept for me, but it's that hot reload where I type a little bit of code and then my game just automatically gets rebuilt. That's called watching local file changes and then doing the rebuild. So all that becomes quite fun to use, and I've enjoyed it. So here's the project overview. The environments that you're gonna have is your code editor open. I've got kind of three areas here shown in the screenshot. The file browser, which is called Explorer, then the terminal, which is where you're going to be typing those commands like install this and rebuild that, and then your code editor, open where you're actually doing some code changes. So the code that we see here is a flavor of JavaScript called TypeScript, and I've done everything in this demo to use TypeScript. If you're not familiar with the distinction between the two, don't worry about it. Just go with TypeScript. It is a stricter language, but gives you a lot of development workflow improvements, better syntax, etc., better syntactical highlighting as well. And then the second part of that is that as you're developing, you tab over to your browser where you would see the game full screen like I showed you, but you can also open the developer console. And there's a particular one which I have commented in the template code itself called the PixiJS Dev Console. So here we see the browser on one side. It's still the browser, but some helpful panels here. The upper right here is showing the PixiJS Dev Console. Now, if you're familiar with Unity or Godot, that is like the scene hierarchy concept from Unity or Godot, where it shows a tree of all of the different objects that are on the screen, as well as being able to click those and be able to tab in and manipulate some values. Super helpful. Now, that is a community-based tool. I'm not sure if that's created as part of PixiJS, but I downloaded it separate, and I can't recall if that's created by the organization or not. And then the console window there, which is like your Unity console, you're able to put some commands in your code and be able to have the code reflected here. And then a nice added thing that you can do here is type actual TypeScript or JavaScript in here, calling methods on your game perhaps, and it's like a God mode console in a classic FPS game where you're actually able to code some stuff while looking at the game. I wouldn't say code really, but let's say call commands or check the values of certain things. So just between those two windows, you've got your code window, and then you've got your browser window, and you do your development there. You can take a deeper look if you browse to the link here, and you can see all the different structure, but there's some callouts for some particular subfolders and stuff like that that's interesting. Now, this is the type of thing that I hope you find useful. For me, it would have been amazing for me to find this resource from the beginning of my learning. I've only spent a couple days learning this technology, but I'm enjoying it so far. So the project details here, these are some of the different editor tooling that I'm using. Visual Studio Code, and a couple plugins that I found useful. And then this is a partial list of the coding packages. So remember I mentioned before, you download or you fork this project that I have here, you run that npm install command that I have listed, and it automatically gets all the things that you need, all the packages and dependencies. I just wanted to call out a particular subset of them that I think are interesting. So some of the plugins that you bring in, or libraries that you bring in, are for runtime use. So all the PixiJS ones are here. But notice that there's a few different ones, and there's a much more that I didn't bring in for this project. For example, if you want to have particle effects, there's a different package that you would download for that. I didn't include it in the template. Here I'm just using UI, actions, filters, and the core library itself. Then there's some editor time tooling and stuff as well. Webpack is what kind of builds this project up and does that watching feature and rebuilds it when you make any code changes. TypeScript is the kind of optional add-on that you ripple through several different areas of this setup so that the code is strongly typed and it's a more strict dev environment, which I think is really worth it. ESLint, I would tie in with the quality of life of JavaScript. It is able to make your code look prettier inside the editor by doing some tidying and some cleaning up. These are all links here you can check out if you can get deeper into it. And then I consider CI/CD and unit testing essential for game dev. So the CI/CD I'll cover separately, but Jest is the tool that I've used for the unit testing. So unit tests are non-production code that sits next to your code base, and it tests the environment. So if you're not skilled or experienced in doing unit tests, you can follow along on my series and see how that's useful. It's tremendously powerful, and I really love the fast feedback you get here within this JavaScript environment. It's something that I do in Unity and in my Godot work as well, and I love having it plugged in. It's not a requirement in the kind of hot path to being a developer in either of those tools or in game dev in general, but I really consider it an amazing foundation on which to build serious projects. I've also got a link to some best practices here. Now, these things are related mostly to Unity and to Godot, but I hope to expand these best practices out specifically to JavaScript and TypeScript and maybe not PixiJS per se, but the HTML5 world, and add that in here, and I'll update that list. Imagining that you've either forked or downloaded the code from the project template repo as a zip, you can open it up here in your favorite code editor. I'd recommend using Visual Studio Code. It's very popular, it's completely free, and it has some of the plugins that I thought were really useful for along the way. Generally in my development for C# based projects both with Godot and with Unity, I use the Rider paid editor. I'm not sure how friendly Rider is for this type of development. It might be just as good, but I decided to kind of go down the cow path that a lot of web devs and HTML5 devs use, which is VS Code. So this is a pretty cool tool. I'm familiar with it in general. I've used it for a lot of kind of side projects and stuff like that outside of game dev. But here I found it really cool. So we've got these three areas open that I mentioned before. The screenshot's a little flipped because I've decided to put the Explorer on the right side here. So we've got the different folder structure here. Now, as I'm completely new to this, you may have different suggestions on better ways to organize the project, and by all means share below if you find a better folder structure than what I've got here and have some suggestions. But some of the highlights here is that this public folder is the place where the HTML is that actually gets loaded, and we'll see that in a second. The source here is where your scripts go, and then tests here is where I've got the unit tests. Now, I'm not going to cover the unit tests in this video, but in the future, you'll be able to check that out. And the idea here is that tests are completely separate than your production code. They're not really interesting for your end user directly. They don't get into that distribution, but they're used during development. So if we're here for our very first time, we would do npm install. Now, I've already installed the packages here, but that's the first command that you would need to run. I'll also type clear here to just clear out the console. The next thing you'd need to do is build your project. Now, this is going to convert the code that you're working on into something that can be enjoyed or played. So npm run build. There we go. That's done. And if I'm not mistaken, what that does is it repopulates this dist folder, which is the distribution. If you were going to have this be playable, you would only need someone to have the dist folder, and maybe not even all of it. I'm still learning. You can see it's divided up into a bunch. And here's that index file. So this would actually be run. So if you put this dist folder, if you email it to a friend, or if you put it up online, that's all that you need to actually enjoy the experience. And then lastly, let's run a server so that we can see the game being played. And it's friendlier than me like copying and pasting the dist folder somewhere. We're able to do that in a more live and friendly way. So that is going to be npm run and start. And there's different flavors I've got here. You can see it's auto-completing start with test, but I'll just do run start. Now what this is going to do is start up a local server on my machine and make this playable for just me. So you can't like send this link to a friend and have them play it live because this is only running on my local machine. But I end this here with success, play via browser, and then you click here. So I'll open up that link. And then here's that running again. Then I can hit F12 to open up this development panel, go to PixiJS, and then here we are. Now here we're in the development environment that we saw from the screenshots. So you would really just tab between here and do your work. So let's say that we wanted this sprite to be placed in a different place. Well, we could edit some code and hit save and then pop back here and it would be done. Let's take a look at the code of the template and maybe make a code tweak just to see that as the last step. We're not really going to do much development here. I'm just introducing the code template. So the entry point for the code template, we're going to go to source and scripts. And then we've got two files of interest here. The index.ts, which is the TypeScript file. And then I created a flower SuperSprite, which represents that flowery mandala pattern that we've got in the middle of the screen there. So I'm going to go through this quite quick. I'm not really trying to teach PixiJS per se. I'm just giving you a flavor of the types of stuff that I found interesting while creating this template. This template, again, is not meant to be a game or really even the starting point for a game. It's just meant to be how to have just enough code laid out in a nice systematic way to render something on the screen and then be able to have that nice workflow. So up here, we've got the import statements that bring in different libraries of interest. Then we've got some Pixie configuration to sharpen the graphics. Then I organize the URLs that you might have in a project. So here's the local file for that mandala flower that we've got. Now I've created, for the sake of learning and also for use, a couple of custom classes on top of PixiJS. So I have two. I have one called Super App and one called SuperSprite. Oh, and then a third one, the Flower SuperSprite. But the Super App wraps the PixiJS app and does some things nice for us. So you're invited to use Super App and SuperSprite if you want to get started making your first game. Then next, there's a weird looking line that is required by some documentation in order to get that nice editor window to pop up next to our running game. So I just did that. Then we have a couple of function callbacks for some key moments. So when the Super App gets initialized, this is where you listen and you do your entire game logic here. So basically, this part right here, at least in this simple scope, represents 100% of the game logic. The rest of the stuff that we'll be scrolling through is just kind of setting that up. So let's look at what we do here. Well, we use the Pixie assets load to go and load that URL. So now it's ready in memory for usage. And then we make a texture from it. And then we pass that texture into the flower sprite, and then we add it to the stage. So it's like preparing your assets, then putting those assets into a sprite, which is one of the conceptual objects, but it's a pretty popular one. So I think Pixie Sprite is something like a game object as kind of a central idea, game object referring to Unity, or a node if you're into Godot. And then you pass that texture in there, and then it gets rendered. So let's look at that flower SuperSprite. So Flower SuperSprite is meant to be something game specific. So it's not so important to have flower graphics in your game, but it just represents kind of a game specific level implementation. SuperSprite I would find very reusable, and you might reuse SuperSprite. So let's take a look at three key things here. I want to look at the constructor and then two things after that. So the constructor here, I'm going to give it a label, which helps it show up in the debugger as a particularly nicely named thing. It's just optional there. Then I make it rotate from its center point by setting the anchor, and then I set its scale. So its scale is probably automatically 1, but I just wanted to call this out explicitly in case you're curious as you look at the demo. How do we do it at half size? You would just change to 0.5. Second, this SuperSprite SuperSprite handles resizing. So it takes in a reference to the application itself, which gives you the ability to look at app.screen.width and height. So one of the key things you may want to do is have your game be responsive and be able to move around as different layouts happen. So that could be as the user is changing the browser window manually using their mouse on a desktop, or you just load it in a Samsung phone versus an older iPhone, and each of those have a different screen layout. And when that first app gets loaded up, it's going to catch this and be able to resize properly. Now, I'm still learning how to resize. In fact, recently I was doing a demo project and I didn't do it so great. So it's something I want to learn better. But the idea of internalizing it here and making it a first-class citizen inside the SuperSprite was important to me. In the Unity world, you can do these types of things when you make what's called a liquid layout or responsive layout. In Unity, you typically think only of doing that with your UI, at least for most types of games. And you expect the viewport into the 3D world to be less important about being liquid, so to speak. Also, Unity is meant for one platform at a time. So when you can make a cross-platform game, you generally know more than HTML5 what screen aspect ratios you're going to be supporting. So the same issue exists there, but it's not as high priority. Here, you're assuming by the nature of deploying HTML5 that you're deploying for a variety of browsers on all the different machines, desktops, laptops of different sizes, and then mobile, of course, where there's hundreds of different devices with different screen ratios. So here there's a bit of custom math that you would either skip if you don't care about resizing, or be able to copy and paste and modify this as you need. This is really just designed to keep that graphic locked to the center of the screen. And then the third and final thing I want to look at is the concept of onTick. So you get a reference of the ticker, which has some helpful values, including delta time. So if you're used to Unity, this would be like your monobehaviors update, where you also get delta time. And delta time, you want to more or less use that and multiply it into any movement or rotation that you do in your game, and it just helps smooth out all of the movement and animation that you do. And in Godot, this would be like the process on a node that you have, a node 2D or a node 3D. Again, using delta time. The ticker has some other helpful stuff as well in that object, but delta time is the most important. So this is what's going to slowly move that over the course of the running game. So that's all of the template code that I want to look at. Here's one more peek at just the end result. And I will show here that as I drag this in and out, we have that object staying locked to the center of the screen. I'm choosing not to do any resizing here, but you could have it resize as well. That seems like it might be automatic behavior, but it is not automatic behavior. You have to use that last chunk of code that I mentioned. Then also with the PixiJS DevTool, I can mouse over here, select objects, and see properties about them. This is kind of like the Unity inspector or the Godot inspector. And then down here, you'd be able to see any console log statements. So it's a pretty friendly environment overall. I would say probably with some of the other JavaScript frameworks that are competitors to PixiJS, this would represent maybe in the middle of the friendliness of the workflow. There's going to be some JavaScript frameworks that don't have the equivalent of this PixiJS DevTools window, but you would still have the browser and you'd still have the console window, etc. And then there's going to be ones that are more friendly, so to speak, like Play Canvas that I'd used for a couple of years ago. I did some Play Canvas work. That has an editor itself, so something you open up that's kind of like Unity, and you're able to visually lay out your world and do your debugging and stuff through that. And that is available in the browser too as an editor, so that's super cool. That would be kind of on the higher end of the warm and fuzzy feeling you'd have as a dev. So that's all we're going to take a look at here. We took a deeper dive into some of the issues within PixiJS and what PixiJS offers. Moreover than that, I explained a little bit about my path to getting into PixiJS and how I didn't know anything about how to even set up a project. And then over just a couple days time, really, I was able to make this template, the earlier version of it, make a few examples on top of it, and then finally come back and be able to polish this up. I spent maybe a day adding unit testing, making the code look a little better, coming up with the concept of the SuperSprite to wrap some of the functionality for resizing and for ticking that I mentioned there. And if I was building a game with PixiJS from scratch, just as a solo dev, I would start with this template as a great place and a great working environment to be able to build on top of. So thanks for checking out the template. I would absolutely love if you fork or download it and play around with the template and give me any feedback here on this video, or through Git, submit any Git issues if you want to add to it, or make any pull requests to fix any bugs. There's not too much code happening in there, but I would imagine that maybe different folder structures or different optional libraries to bring in and help smooth out the whole dev workflow would be recommended by the community here, people who know much more about it than me, and I'm interested to learn. So thanks.